we're starting on Unit 2.4, graphs of functions. There's kind of a lot of little stuff in here. I wanted to start with the problem 1. It's like some of the ones you're going to have to do. And it asks us to give the domain and range and tell whether it's a function. So a really goofy little problem. Our domain is just going to be the x values they give in these points. We don't really know what's going on here, but we've got x and y values, and that's all we know. So our domain is just going to be 2/3, 6.7, 3.1, and 4.2. Now, I think you just have to enter the numbers into the homework app. I don't think you're required to use brackets. Usually set notation takes curly brackets. All right, so the range. Well, these are just our y values. So when x is 2/3, our y value is 3. And moving along, we get 1.2, 1.4, and 3.5. And then lastly, they ask if it's a function. Okay, the only thing that makes it a function is whether or not the x values give us a predictable y value. And we have to assume that's the case. So yes, it is a function. Now, when is it not a function in this table format? That will happen if, say, you have an x value that gets repeated. Say this point, instead of being 4.2 and 3.5, was 3.1 and 3.5. So what we have is the same x value of 3.1, but we get 2 different y values out. That means that it's not predictable, and it's not a function. So just look for those repeating x values, and if you get 2 different y values, then it's not a function. Now, keep in mind, it's okay to get repeating y values for different x values. So for the function x squared, you put in x equals positive 2, you're going to get a y value of 4. If you put in a negative 2, you're going to get the same y value of 4, but it's predictable based on the x's. So it's the repeating x's with different y's we're looking for. That's the way we tell it's a function or not when it's a table or a set of points. All right, so example 2, graph the function without using a graphing utility. I only included this because it shows up in the homework. That just means you can't cheat and look at it on a grapher. By the way, even looking at it on a grapher isn't going to really help if you don't know exactly where this function goes. So what I want to do is I want to show you graphing this. I probably should have shown it to you, I think 2 sections ago, but I'm going to show you graphing this on the graphing utility. So my function is negative 1/3 x plus 4. So what I'm going to do is I'm going to select the line with 2 points. I'm going to go to my y-intercept of 4, and then I'm going to go down 1/3. All right, this does not work as well if I'm not holding a pen. Let me try that again. Or actually, I just need to use this. So 4 down 1/3. There's my line, and graphing utility, you should be happy with that. So use the y-intercept in the slope when you're given one like that. Okay, so back to the notes. And determine the domain and range. Look, it's a linear function is a type of polynomials, and linear functions in particular have a domain of all real, and let me use that. So domain of all real, that means negative infinity to positive infinity. So there's our domain. Our range is also negative infinity to positive infinity. The domain can be restricted on certain kind of polynomials like quadratics, but they're not asking us about a quadratic, but that's coming. All right, graph the function and determine the domain and range. So it's really helpful to think of transformations if you're graphing these functions. For example, h of x, we can think of that as negative x plus 0 squared plus 1, which means our vertex is at 0, 1, and it opens down. Okay, so that means that it opens down, so 1 is our highest y value. So our domain is, again, going to be negative infinity to positive infinity. That's always the case with quadratics. but our range gets restricted depending on the min or the max. So here, this one says, and I'm going to graph it in a second, it says that it's going to open down and our maximum y value is at 0, 1. So that means that we go from 1, including 1. Actually, we have to do it backwards because this is opening down. So we're going to put in negative infinity to positive 1. All right, let's take a look at how this graphs on XYZ, though. Okay, so this is one where we're graphing a quadratic, and I'm going to graph where my vertex is at 1, 0. So I'm going to pick the parabola. You start with the vertex, and then you graph any other point. Now it's opening down, so I'm going to go to my next point. I also know it's not going to expand or contract because it's not going to get wider or narrower because I don't have a number multiplying with my negative. The a is 1. So that means it's going to have the same shape. Remember, we start at the vertex. If it's the same shape as the parent function, it's over 1, up 1. But since we're opening down, that's over 1, down 1. And that is good enough for the XYZ homework. So just press submit. And now I'm not doing this particular problem. I'm just showing you how to graph this particular problem. I'm not going to hit submit because it's not the problem it's asking me about. Okay, so back to the notes. We've got our, I'm just going to sketch it. We've got our graph. 1, 0, opens down, and there's our domain and range. All right, I gave you B, which is already in vertex form. That means our vertex is at, we move, it's negative 4 here, so positive 4, we move right 4 and up 0 because we don't have any number being added. Again, it's gonna, this one it has a positive A, okay, so no number there, we assume it's positive. It's gonna open up, and our domain is the same, it's all real, but our range is going to be from 4 up, so 4 to positive infinity. Let me show you how we graph that one. Okay, so I'm going to start with my vertex at 4. I can put a point either here or here, and there's my parabola. And I will see you on the next video.